Hello students, in this lab session we will learn the 10th program of your AI lab, which is a natural language processing program. Natural language processing. The question is, using Python NLTK, that is Python library for natural language processing, perform the following natural language processing task for any textual content. Textual content, you can give it directly in your program. You have to perform the following tasks. First one is tokenizing, then filtering the stop words, stemming, part of speech tagging, and then performing the chunking. So in order to perform these tasks, we need a number of libraries which we need to import it. So these are this is called the data pre-processing or importing the necessary libraries. That is from nltk.corpus you are importing stop words, nltk.tokenize you are importing word underscore tokenize, and nltk.tokenize you are importing sent underscore tokenize. Then again for porter stemmer for stemming purpose and word tokenize. Next in your program, moving on to your program, initially you have a function definition, that is remove underscore stops of text. This function definition is for removing the stop words. Stop words are nothing but those words which doesn't add a special meaning in your word, like I have a car. In this word, I is a stop word, a is a stop word, and so on. So unimportant words, removing the unimportant words, you call it as stop words. So for that, this is the function definition, where the function name is remove underscore stops of, and the text you have to pass, whichever text you want, you have to pass it here. Filtered underscore list is equal to, you are initializing an empty list here. Next, you are using a for loop for word in text, that is each word in the text. If word dot case fold of not in stop words, that is you are checking whether it is present in the stop words or not. You are downloading the stop words here. So under this NLTK, you have a list where the stop words are being listed. So you are checking whether that particular word is there in the stop words or not. If it is not there, then filtered list dot append of, into the filtered list you are adding that particular word. Return the filtered list. Now this filtered list will contain the list of words which does not contain the stop words. Okay. Next we will start with the program. Yeah, this is a comment line. See, for each of these, you need to download it. You need to download this nltk.download of stop words you have to do. That is in your spider. If it is giving the error, you have to go here in the console and type that download stop words and press enter. It will get downloaded. All the stop words will be downloaded into the file. Now I'll just run this program and get the output and then explain the program. Once you click on the run button, yeah, you can see the output here. This is the output generated. These are the output plus one more output is there, this one. So we'll go one by one. The first, this is the remove stop words function definition it is. We will begin from here. First, your entry, that is in the program itself, you are giving a string which says, I will walk 500 miles and I would walk 500 more just to be the man who walks 1,000 miles to fall at your door. This is a sentence which you are copying or assigning it to the variable string. After assigning, you are going to tokenize this string. Tokenize this functionality, word underscore tokenize comes under the NLTK tokenize here. This one which we have imported. So what it will do is it will tokenize each word of this string. Every word. See, every single word it will consider as a token and it will tokenize it. Here now what you are doing, you are printing this tokenized form. Print of W. This is the output here for this print. You have tokenizing this one. This is the tokens. It will consider all the words as tokens. I, will, walk is a token, 500 is a token, miles is a token, and is a token, again I is a token, wood is a token, walk is a token. So this is the output for this print statement, printing the token words. Next functionality in your program is, after tokenizing, what you have to do. These are the functionality. First functionality task you have to perform is tokenizing. Tokenizing is done. Next is filtering the stop words. Filtering the stop words. For that, what you are doing, set of stop words dot words of English. That is stop words in English. You are assigning it to the stop words. Whatever you have downloaded using the stop words, you are assigning it into the stop words. And then what you are doing is remove underscore stops of W. That is, you are calling this remove underscore stops function here. This is the function definition. So you are calling this function and you will get the filtered list where you don't have the, after removing the stop words, the filtered list will be stored onto this variable filtered. Now we are printing this filtered list. Stop word removed list you are printing using print of stop word removed filtered. If you print, you will get the the file which consists of the words which doesn't have the stop words. You can see here the output for this print statement, stop word removed, and then the file. See here in this file you don't see this I, then and I, all these are stop words. These words are removed and only the important words, that is walk 500 miles, would walk 500, man, all these will be, other than the stop words you can find in this output after removing the stop words. Next task which you have to perform is stemming. Stemming is nothing but, see, when I say, if for example, if I have a word called interest, the stemming words of interest are interesting, interested, interest. So such words you call it as stemming words. Now, using stemmer, what you are doing is the extra words, that is the base stem of that particular word only you will retain. The rest you will remove. That is, if you have interested, interesting, interest, these two words, out of this it will take only the interest. The rest will be removed. That is called stemming. So here we are performing the stemming of the words. Porter stemmer of, you are calling this functionality which you have imported from the NLTK.stem library, Python library. Now Porter stemmer of, and then you are storing it to stemmer object. Now stemmer.stem of word, for word in W. For word in W, that is word W is nothing but from this tokenized list. Okay, from the tokenized list you are performing this stemmed words. You are printing the stemmed words. After stemming, you are printing the stemmed words. So print of stemmed, and the list of stemmed words you can see in the output. See here, the stemmed list is here. This is the stemmed list. If you observe here, you can see, miles. In the previous this one, the token was miles, whereas after stemming, the result is mile. Understood? Again, one more. Here you have walks. The stem of this walks is walk. This is a stem word. So this is called stemming. Next, what next task which you have to perform is part of speech tagging. So how to do this part of speech tagging? For that, you are initially taking a sentence. This does the part of speech tagging. The cat ran across the road. Part of speech tagging is nothing but, see, for each word you have the type of the word that is part of speech, whether it is a noun or adjective or past adjective and so on. There is a list in your NLTK. According to the list, it will give you the word and the part of speech. So the cat ran across the road. This is the example sentence. You are storing it into the variable sent. Next, what you are doing, word underscore tokenize of sent. You are tokenizing the word and storing it in TOK variable, and then you are applying NLTK dot pose underscore POS is nothing but part of speech underscore tag of TOK, and then the result you are storing it in POS underscore tags. Next, you are printing the part of speech tags. Print of POS tags is equal to POS tags. In the output, you can see the POS tags list. This is the POS tags list for each word. The, see, the first word, the, it is showing DT. DT is nothing but determinant. The second word, determinant word it is. The second word, that is cat. Cat is, and then it is displaying nothing but it is saying that it is a noun. Again, for ran, it is showing verb, past or past, it is past word. You have a list which shows in under NLTK. You can see the list where you have the abbreviations. CC means coordinating conjunction, then DT means determiner, then IN means preposition, and so on. VBD means, you can see here VBD. Yes, VBD means verb past tense. So like this, a list is there under NLTK POS tags. You can check out this list to understand this. What is this? And then what is IN? IN across is a preposition and so on. So this is called part of speech tagging. Next, after this, the next task to be performed is chunking. Chunking is nothing but you are grouping the small words into big words. That is, chunking in natural language processing is a process to take small pieces of information and group them into large units. You are going to group them into large units. Rules for chunking. So usually you have some grammar rules available, and any grammar rules you can select for chunking. In our program, we will use the grammar rule. Yeah, here you are specifying the grammar rule where it shows the what is that, noun. We are performing the noun phrase chunking graph. Noun phrase chunking graph. If you see to this graph, this is your output which you are getting according to the given grammar in the program. Now, from the graph, we can conclude that cat and road. This cat and road are two different tokens, but they are categorized under this noun phrase chunking. And the determinant also. So here the grammar rule, what it says is, under noun phrase, you are categorizing this DT, JJ, INN. This is JJ is nothing but adjective and noun, etc. So this is the grammar rule you are giving. For the grammar rule also, for each abbreviation you have the name of the symbol and description. Like dot means any character except new line, star, question mark, etc. This reference file also I will upload it in the Google Classroom for your reference. So this is called chunking. After performing the chunking, parser.postx of. After performing the chunking, in the last line is for printing the tree dot draw off. You are drawing a, you are plotting, that is drawing a tree for after chunking. This shows when you run the program. After you run the program, you can see a file here. This is the output for the last line, that is it is forming a tree. From this tree you can understand that under noun phrase you have this the cat and dt, the road and everything, but this preposition that is across doesn't come under the noun phrase chunking. So this is all about the 10th program, which is natural language processing. The task, few tasks performed under the natural language processing. So the output is this plus the tree. This tree is your output. Thank you, students.